Good morning, all. In previous lecture, we have seen the examples related to De Moivre's theorem and their properties. Of course, we have applied the De Moivre's theorem and their properties in a reverse order also. So, next point is we are discussing expansion of sine n theta or cosine theta. So, here how to expand instead of n in example there will be the number, that is we have to expand sine 4 theta, sine 5 theta, sine 6 theta, etc. because the lowest numbers are not there, that is sine 2 theta. We have already the formula for sine 2 theta or cos 2 theta, that is double angle formula are there. Sine 3 theta or cos 3 theta, that is triple angle formulae already we have. Hence we have generally in exam expansion for sine n theta or cosine theta. So there will be the examples for n equal to 4, 5, 6, etc. So here for expanding this sine n theta or cosine theta, we have to use the well-known formula we have studied in previous lecture, that is De Moivre's theorem in reverse order. So De Moivre's theorem is cos theta plus I sin theta bracket raised to n equal to cosine theta plus I sin n theta. So now to expand sin n theta or cosine theta, we have to use this De Moivre's theorem in reverse order. So in reverse order means in De Moivre's theorem, this is your LHS, this is your RHS. So to expand this type of functions, sin n theta or cosine theta, we have to take this as left side and this as a right side. So again there is a expansion in the expansion of sin n theta or cosine theta, we have to use the Pascal triangle. So here the Pascal triangle is used to expand the bracket cube, bracket square, bracket raised to 4, bracket raised to 5, etc. So here a plus minus b bracket square, this is the well-known formula, don't need to use the Pascal triangle. So a plus minus b bracket square is a square plus twice ab plus b square, this is for plus, and for minus sign there will be minus sign to the middle term, a square minus twice ab plus b square. Then again there is a expansion a plus minus b bracket cube, a cube plus 3a square b plus 3ab square plus b cube, or for minus a minus b bracket cube, alternate plus minus signs we have to put, that is plus minus plus minus. Then what is the formula for a plus b, a plus minus b bracket raised to 4, a plus minus b bracket raised to 5, etc. So how to get the expansion of this type of brackets? So here for Pascal triangle, first two lines we have to remember, that is take one number, then below that take the three numbers 1 2 1 in this position, then we have to add these numbers and write the number in between these two numbers 1 and 2 below these two numbers. That is again the Pascal triangle means this shape you can see as a triangular shape. So in triangle the edge numbers will be same, that is we have to take 1 1 1 1 1 1, then again in fourth line the end numbers should be 1 1, then 1 1, etc. And the first two lines will be 1, end numbers are 1 1, the middle number is 2 1 2 1. So 1 1 2 1, these two lines we have to remember. Rest of the lines we can calculate. So here take this end numbers 1, write in the pyramidal shape, take the one number, then add these two numbers, 1 plus 2 is 3, then again 2 plus 1 3, and again write there is no any number in front of this one number, this is your last number, hence write the one number as it is, there is no any addition further. Now again take this one number first, then add 1 plus 3 4, then 3 plus 3 6, write this 6 number in between these two numbers, exactly below these two numbers, that is here. Then 3 plus 1 4, and again there is no any further number, this is your last number, hence write the end number as 1 again. Again take one number first, then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then no further number, hence take end number as 1 again. So the next line you can calculate, that is 1, 1 plus 5 is 6, 5 plus 10 15, 10 plus 10 20, 10 plus 5 15, 5 plus 1 6, 1 plus there is no any further numbers, hence write again 1. So this pyramid you can obtain by using this method. So how this Pascal triangle is used to expand the bracket raised to some power. So here these are your coefficients. So you can see for a plus b bracket cube, so a cube coefficient is 1. So for cube, this is your third line coefficient we have to use 1 3 3 1. So here a cube coefficient is 1, a square b coefficient is 3, ab square is 3, b cube is 1, that is 1 3 3 1. So these kind of coefficients we can get directly and we can expand these types of brackets. So here how we can expand a plus b bracket raised to 4. There is no any need to remember the for minus sign, because write the terms by taking a plus b bracket raised to 4 expansion, and for minus sign alternate plus minus signs we have to put only. So plus minus plus minus plus. So that is the only difference for expanding the minus brackets. So here a plus b bracket raised to 4. So first for raised to 4 we have to use this fourth line 1 4 6 4 1. These are your coefficients 1 4 6 4 1. So how to take these coefficients? Take 1, then take a raised to 4, first term raised to 4. Then further we have to decrease the a power, that is a raised to 4. Then next term contains a cube, next term contains a square, next term contains a, next term contains, that is the a is absent. So this kind of rule is there. So first take first number raised to whatever the power a raised to 4. Then as we are expanding plus, so all the terms having plus sign. So plus further coefficient is 4. So 4 decrease the power of a raised to 4, that is a cube. And when we are decreasing the power of first term, that time we have to increase the power of second term, that is we have to take, we are decreasing the power of a raised to 4, that is 4 decreases to 3. So a raised to 4 is first term, then plus coefficient is 4, decreasing power is a cube. As we are decreasing, increase the power of b. So take the b first because it is starting from this. So b plus next coefficient is 6, a cube decreases to a square and b increases. Second term powers should be increased, and first term, this is your first term, this is your second. First term power we have to decrease. So here a cube, then next term is a square, here b, so the next term we have to increase as b square, the power should be increased, b square, plus next coefficient is 4, a square, then next term is a, and here b square, next term is b cube, plus here a raised to 1 is last term, hence we don't have to take here a should be absent, and then increase the power of b cube. So b cube, next coefficient is 1, 1, b raised to 4. So this is your expansion of bracket raised to 4. For minus sign, take plus minus plus minus plus. Now you can easily understand what is the bracket raised to 5 expansion. So for bracket raised to 5 expansion we have to use first line, second line, third line, fourth line, fifth line. So this is the similar way you can remember that. For fifth expansion we have to use fifth line coefficients. So the coefficients are 1, 5, 10, 10, 5, 1. So take 1 first term bracket raised to whatever the power we have asked, a raised to 5, then plus next coefficient is 5, a raised to 5, then decrease the power a raised to 4. simultaneously second term b plus next coefficient is 10 a raised to 4, then a cube. We have to increase the second term power. So here b, so b square plus next coefficient is again 10 a cube, then decrease a square. Here b square, then increase b cube plus next coefficient is 5. Here a square, decrease the power a. Here b cube, increase the power b raised to 4 plus next coefficient is 1 b raised to, here last term is a, so absent, here a is absent, and we have to increase the b raised to 4 power, that is b raised to 5. So here we have to stop. When we have to stop, the end terms will have the power which we have asked. So here we have asked fourth power, hence a raised to 4, the end terms having the power 4. A raised to 4, b raised to 4. A raised to 5, the power is 5. So a raised to 5, b raised to 5, etc. So in this way we can use the Pascal triangle coefficients to expand the brackets. So this we have to use to expansion of sine and theta or cosine theta. So here again, in expansion or in this type of examples, we come across the many powers of I. That is, for example, we know that I value is square root of minus 1, then I square is square root of minus 1 into square root of minus 1, that is root minus 1 is root minus 1 square, that is minus 1. I square value is minus 1. Then what is the value of I cube? Split the I cube as I square into I. So we know I square value is minus 1. So these two values we have to remember basically. So I square value is minus 1. Minus 1 into I is minus I. Then keep this I as it is. No need to further simplification. Then how to find the value of I raised to 4? So here I raised to 4 is equal to, I raised to 4 means I square into I. We have to split the power of that I into second power. That is splitting into 2 power. It is important in these types of terms. So I raised to 4. I raised to 4 we can split as I square into I square, and we know the value of I square. I square is minus 1 into minus 1, that is totally is 1. Then what is the value of I raised to 5? I raised to 5 you can split as in the power of second power, that is I square its square. So the total power we have asked 5. We are splitting this 5 as into second power. So I square raised to 2, because we know the I square value. Hence we are splitting the power 5 into 2 power, second power. So I square its square. So total is 4. So remaining 1 we can multiply by I. So I square value is minus 1. So minus 1 square into I. Minus 1 square is 1, that is I. Then how to find I raised to 6? I raised to 6 is I square its cube. We have to split into I square form. So I square raised to 3. So total power we have asked 6. So it is matched. That is total power is 2 into 3 is 6. So I square value is minus 1. Minus 1 cube is minus 1. Then what is the value of I raised to 7? I raised to 7 we can write as I square raised to, what is the nearest number to this 7? That is I square raised to 3. So total power is 6. Total we want 7. So there is only 1 remaining. So we have to multiply I. So I square value is minus 1. Minus 1 cube into I, that is minus I. Again you can find any number I raised to, you can take 35, 36, any 35. Take 35. Then split this I square. What is the nearest power or nearest number to this 35? So 2 into 17. So 2 into 17 is 34. So total 34 we get, but we want 35. So here we get 2 into 17 means 34. Total we want 35. So only 1 remaining. So for 1 multiply by I. So I square value is minus 1 raised to 17 into I. So negative number raised to odd number is always negative 1. That is minus 1 into I, that is minus I. Again this is a odd number, you can take 46. So what is the I raised to 46? We can find easily. So take the power I square raised to, what is the nearest number? So we can divide this 46 by 2. So here 2 and 3. So total is 46. So we get whatever we want, 46 we get directly. So 2 into 23 is 46. So we get total I, 46I. 23 into 2 is 46. So I square value is minus 1 raised to 23. Minus 1. So negative number raised to odd number is always minus 1. And minus 1 raised to even number. This is your even number. So minus 1 raised to even number is always 1. Minus 1 raised to odd number is always minus 1. So this rule you can use and find any power of I by splitting into I square form. So here, so these some points or some terms we require to expand this sine and theta or cosine theta. So here Pascal triangle to expand brackets, then these ith power, how to simplify this the higher powers of I. Now see, let us see the examples. So show that sin 5 theta equal to this term 5 sin theta minus 20 sin cube theta plus 16 sin raised to 5 theta. Cos 5 theta equal to 5 cos theta minus 20 cos cube theta plus 16 cos raised to 5 theta. So here how to understand the given example is this type or not. So here we have to check the left side of that example. So if in this example the left side terms are sine and cos, and there is a multiplication of number to the theta, that is this sin 5 theta is similar to sin n theta where n is 5, and cos 5 theta is similar to cos n theta, that is again there is a n value as 5. By comparing we get n equal to 5. So in this way we can assume that, or we can conclude that this example is of expansion of sin n theta or cos n theta. So here we have to show that this expansion is equal to these terms. So how to solve this type of examples? So here we have to check whatever the value of n. So here n equal to 5, hence we have to use the de Moivre's theorem and we have to put here n equal to 5. So whatever the multiplied number is there to the theta, that number is your n value in the de Moivre's theorem. So here we have n equal to 5, hence put n equal to 5 in de Moivre's theorem in reverse order. So put n equal to 5, so we get cos 5 theta plus I sin 5 theta equal to cos theta plus I sin theta bracket raised to 5. So this is your first step by using de Moivre's theorem and by putting n equal to 5. Which 5? Here 5 is required or asked in the example. Now the next step is we have to expand this right side, bracket raised to 5, that is this is your a, this is your I sin theta is b, so a plus b bracket raised to 5. So we have to use this formula. So use this Pascal triangle, don't remember maximum formulae, then it will be the many mistakes you will do in the exam. So don't remember all the formulae, just remember this Pascal triangle. You can prepare the formulae in roughly. So here a plus b bracket raised to 5, use Pascal triangle. Fifth line as we have asked raised to 5. So fifth line coefficients we have to use 1, 5, 10, 10, 5, 1. Then prepare these terms 1, 5, 10, 10, 5. Plus sign is there. So all the terms having plus sign. And then first term should be a raised to 5. Last term should be b raised to 5. Then a raised to 5, a raised to 4, a cube, a square, a and absent. Then where we decrease the a power, we have to increase the b. We have to take the b. So b, then increase the power of b. b square, b cube, b raised to 4, b raised to 5. Now we have the a plus b bracket raised to 5u. Use this formula and expand this term. So here a raised to 5 cos raised to 5 theta plus 5u a raised to 4 cos raised to 4 theta into b into I sin theta plus 10 a cube b square, a cube cos cube theta into b square I square sin square theta plus 10 a square plus next term is 5u a is cos theta b raised to 4 I raised to 4 sin raised to 4 theta plus b raised to 5u, that is I raised to 5u sin raised to 5u theta. So this formula we are used and we get the terms. Now simplify some ith powers. So write this cos raised to 5 theta as it is, then 5u cos raised to 4 theta as it is, I sin theta as it is, 10 cos cube theta I square value is minus 1. So put I square value is minus 1, then this plus will change to minus sign. 10 cos cube theta as it is, sin square theta as it is, then 10 cos square theta sin cube theta as it is, and I cube value is minus I. So put or simplify this I cube as minus I, then 5 cos theta sin raised to 4 theta as it is, I raised to 4 value is, I raised to 4 means I square into I square, that is 1 into 1, that is there is nothing will change, plus I raised to 5 sin raised to 5. So sin raised to 5 theta as it is, I raised to 5 means I square it square. So total power we want 5u, we get 4. So 1 is remaining to take, so take I extra. So I square is minus 1 square into I, so we get I. So I raised to 5u is I. So I raised to 5u replaced by I. So this we have to simplify. So what we have taken these steps. So first step is we see the left side. In left side there is a multiplication of number 5u to the theta. Hence we put n equal to 5u in De Moivre's theorem in reverse order. Then right side will be your bracket raised to 5u. Using Pascal triangle we expand this, and some ith power, highest powers of I we have simplified. Now we have to take ith term together and without ith terms together. So this is your without I term, that is real part. In short, real part, real part, real part. So take this together, 3 terms, and take I common from these terms, 3 terms, and remaining terms into brackets. So here we get, these are the without I terms and plus I into remaining terms. Now the left side is your cos 5 theta plus I sin 5 theta. So the left side is your one kind of complex number, and on right side also we get the big terms, many terms, but it is also a complex number in the form of complex number. Complex number means you have to get the real part plus I into imaginary part. So we get the right side as one kind of bigger complex number. Now left side is complex number, right side is complex number. We can compare real and imaginary parts on both sides. So here by comparing real and imaginary parts on both sides, so left side real part is cos 5 theta is equal to right side real part is this bracket, cos raised to 5 theta minus 10 cos cube plus sin square theta plus cos 5 cos theta sin raised to 4 theta. So we get what we get, the required answer we get by comparing the real part. We get left side as cos 5 theta, that is expansion of cosine theta. Got it? Expansion of cosine theta, that is we have asked expansion of cos 5 theta. So we get, by comparing the real part, we get expansion of cos 5 theta. Left side real part is cos 5 theta equal to right side real part is this. This is your required term or required answer, that is expansion of cos 5 theta is this. Now compare the imaginary part. So by comparing the imaginary part, we get left side imaginary part is sin 5 theta. Imaginary part means ith coefficient. So sin 5 theta equal to right side imaginary part is this bracket, ith coefficient is this bracket, so write this bracket. So here we get expansion of cos phi theta and sin phi theta by comparing real and imaginary parts of this equation on both sides. Now we get these terms. So what we have a required answer. So in required answer, phi u sin theta, we get sin square and sin raised to 4. Here in this is the answer of cos phi theta. For cos phi theta, we get the cos and sin terms both in the answer. But in the required answer, there should be only cos terms. That is the difference. So this is again the separate part to get the required answer. So we have to use the general trigonometric formula to get the required right side. So as you can see, cos phi theta answer contains only cos terms, and by using this theory and applying this theory to this example, we get sin terms also. So to get required term, required answer, required right side contains only cos terms. Hence we can get the idea that we have to eliminate sin square theta and sin raised to 4 theta. Then only we can convert this equation into cos terms only. So required RHS contains only cos terms. Hence we have to eliminate sin square theta and sin raised to 4 theta. So how we can eliminate this? So here we have to use the formula. Which formula? The general formula, sin square theta plus cos square theta equal to 1. So what is the value of sin square theta? 1 minus cos square theta. So you can convert the sin term into cos term by using this first formula in the trigonometric function, that is sin square plus cos square is 1. Hence sin square theta is 1 minus cos square theta. Replace sin square theta by 1 minus cos square theta. Then again there is a sin term having power sin raised to 4. So what is the sin raised to 4 theta? Sin raised to 4 theta is your sin square theta, its square. So total power we will get 2 into 2, that is 4. So again put sin square theta equal to 1 minus cos square theta here and take its square again. So 1 minus cos square theta. Sin square theta is sin raised to 4 means sin square into square. Total is we get sin raised to 4. Now put sin square theta formula 1 minus cos square theta. 1 minus cos square theta and take the power 2 as it is, bracket square. Now expand this bracket square formula. So cos raised to 5 10 cos cube theta, multiply this to this bracket. So minus 10 cos cube plus minus plus 10 cos raised to, cos cube into cos raised to 2. Total power is 3 plus 2. We have to add. 3 plus 2 is 5. Cos raised to 5 theta plus 5 cos theta as it is. First expand this square. So a minus b bracket square is a square, that is 1 minus 2ab minus 2 cos square theta plus b square. B is here cos square, hence b square is cos raised to 4 theta. Again simplify. First 3 terms write as it is and then multiply this 5 cos theta to this bracket. So 5 cos theta minus 10 cos into cos square cos cube plus 5 cos into cos raised to 4 cos raised to 5 theta. So now merge the same power terms. Cos raised to 5 plus 10 cos raised to 5 is 16 cos raised to 5. Then 10 cos cube minus 10 cos cube is minus 20 cos cube. And cos raised to 5, 10 cos raised to 5 is 15 cos raised to 5. Again, 1 cos raised to 5 plus 10 cos raised to 5, that is 11, and plus 5 cos raised to 5, that is 16 cos raised to 5. Then minus 10 minus 20 cos cube, and this single term, that is right as it is, 5 cos theta. So this is your required answer, because cos 5 theta has the right side this. All the terms contains only cos terms, and we get by the theory sin square sin raised to 4 terms also. So eliminate these sin terms by using sin square plus cos square theta equal to 1 formula, that is sin square theta is 1 minus cos square theta. Again sin raised to 4 theta is sin square its square. Put sin square theta as 1 minus cos square theta, take its square, expand square, and by merging the same power terms we get the required answer. So this is the one example of expansion and by expanding we get the cos term. Now again we have sine phi theta. By comparing imaginary parts we have this term. 5 cos sine minus 10 cos square sine cube plus sine raised to 5. Now this is not a required RHS. The RHS is this. In RHS we have to sine phi theta should be contain the right side as all sine terms, and by theory we get cos terms also. So it is definitely one step we have to do, that we have to eliminate this cos raised to 4 theta cos square theta terms. So how to eliminate or how to vanish these two terms, because we want